Let's talk SOLIDWORKS Plastics. Now, SOLIDWORKS Plastics comes in three different flavors: plastic standard, professional, and premium. Now, the way I like to describe it is it's all about who's using it and what they do. For today's demonstration, we're going to look at plastics standard, which is meant for someone who designs parts that will later be injection molded. Plastics professional is more for people doing some mold work, and then plastics premium is for more advanced mold analysis. All right, so the most basic form is plastic standard, which just looks at the manufacturability of a plastic part, the things that a plastic part designer has control over. So let's take a look at that here in SOLIDWORKS. This is the model we're going to work with, and it's the cover for a smoke detector. And the first thing you'll notice is that it is your SOLIDWORKS environment that we're used to working in. We have our graphics area in the center. We have the feature tree on the left and the command manager on the top. It's the familiar interface here. I'm going to switch to a different configuration and start working in SOLIDWORKS Plastics. Again, all commands we're used to using from our SOLIDWORKS CAD. We'll start with a new study here, and we can give it a name. Then we can start to define different options here. We can get pretty complicated with our analysis here. I'm just going to pick a shell element type. These are for quick simulations of thin parts. Now I have my plastics command manager, and I'll get started with this. The first thing I'll need to do is, just work my way down from the top to bottom. So here I'm going to add an injection location. I'll pick either a sketch point or a model vertex, and this is going to be essentially our gate. This is where the part is going to fill from. And then I'll continue to work my way down from the top, and I'll hit my next option, which is create mesh. Now I'll move the slider to the right, making a more fine mesh, which is basically breaking it up into more pieces or less pieces. To the left, I'll hit create, and this will establish my mesh. And that looks not so good. I'll switch to refinement method here for curvature based. And wow, look at that. By just changing that one option, I get a really good looking mesh. And then you can really get a lot more advanced here with some mesh controls for local refinement, or you can even edit and review the mesh element by element or node by node if you want. But you can keep it really simple, really straightforward by just clicking the mesh button there in the first interface. And once the mesh is created, we get even more options so we can continue working our way down the list. We first have materials, so I can open up the database here to define the metal that the mold is going to be made out of. See, we're capturing a lot of details from the entire environment. Next is the plastic. Now we have this database of thousands of materials that we can sort by family, sort by company. We can add our own materials to it. There are thousands and thousands of materials in this database. For this study, I'll scroll down to number 55, PC here, and just pick a generic PC. I am going to just do a very quick analysis here, and I'm just not picking my vendor yet. I'll go to the process settings. This is where I establish my fill, pack, and warp settings, my standard, professional, and premium settings. Here we're just looking at the filling operation of the plastic part. I can really get into the weeds of the process, or I can leave it all alone with certain settings that are defined behind the scenes, like the melt temperature, the fill time. With all this set up, I'm ready to hit run, and I can run my simulation. Now I will jump ahead here towards the end of the simulation and take a look at the results as it's filling. What's really great about this is you get these partial results. You can see it's been giving me a preview as the simulation actually solves. So I can get some results before it's even done filling. And now that it's done, I'll be able to start looking at my results. So the very first thing I'll want to do is see how this fills. I'll just press play here on the animation pane, and I'll watch this injection molding process, watch this part be filled with that plastic material. It's a very graphical interface here as I look at my results. So I'm looking at all of these manufacturing defect indicators like sink marks or ease of fill plot. This is a very important one, which I'll use for every single simulation. The ease of fill plot gives me that go, no go type check. I can look at other things that indicate the process, like cooling time. And again, everything is graphical here. I click on the plot, I look at the image, and I compare that to the legend. Now, that took a little while to cool, so I'll switch over here to a thinner part and try to use less material and try to optimize the process, try to make it cheaper, right? So now it's a little bit thinner, and I'll use the exact same setup. Every single thing is the same. I'll load the results this time, and I'll take a look at how this fills. All right, so there's my animation of it filling. But the next plot I need to go to is the ease of fill plot so that I can verify whether or not this part can be filled. And in fact, it can. Whenever you see red, or even yellow for that matter, it's indicating a potential manufacturing defect. I'll open up the results advisor here and see exactly what that means. And it's telling me the percentage of the maximum injection pressure, basically letting me know that I'm getting close to the upper limit of my machine I have picked, so I better watch out. Obviously, that cools real quick, but the point of that was to make a part that could be manufactured. So I went a little bit too far in that direction. I'll add a little bit more back to the thickness of this part, and I will take a look at these results. Now again, same setup, just going to load my results, and I will immediately go to the ease of fill plot because I need to know whether or not this fills. Because if I'm making a part that isn't even manufacturable, then I have some serious issues. So first things first, this can fill. How do I know? Well, it's all green. The cooling time, we're looking at less than 30 seconds. So cut our cycle time or part time in half. So we're trending in the right direction. We're really doing a good job of working on this part here. Now, I do need to look at the weld lines or knit lines. How is the flow front coming together? And it looks like these weld lines are in places that my boss told me I can't have that. So let's move around the injection location to make sure that we're moving around our weld lines. So now, instead of it being there on that flat face on the edge of my model, I'll put it over towards the top longer edge. And I'll load my results. Again, exact same setup, except the injection location is slightly different. Again, the first plot we're going to go to is our ease of fill. We always need to look at whether or not this can be filled, and it is. Great. So now I can start to continue my analysis by looking at my weld lines. And I've moved them over to an appropriate location, right? Something I can cover up, something that isn't structural. It's just in a good spot, right? So now that I've done that, the only other thing I want to do is try to reduce the maximum pressure it takes to fill this, okay? So I've worked on using less material. Now maybe I can use a smaller machine, always trying to save costs here. Now, everything in this study is the same, except for one thing. The material is different. This time, I'm going to use an ABS polycarbonate blend because the previous study showed me that the pressure required to fill that material was over 50 megapascals. I'm going to look to reduce that. And if I look at, again, my ease of fill plot, always wanting to look at my ease of fill plot. Now, for this, I wanted to keep it under 30 megapascals. I can use a machine that's a lot smaller if I keep it under that level. And I see 27 or so megapascals for filling. And that's SOLIDWORKS Plastics Standard, the tool meant to be in the hands of a plastic part designer, because he or she can then check the implications that the geometry decisions have on the injection molding process. An invaluable resource for anyone designing parts to be later injection molded.